and this is the Faculty of Science and Technology interface. In Faculty of Science and Technology interface, we have three departments: physics, chemistry, and mathematics. And now let us talk about the research facilities. At present, in the department, we have five, or you can say six, research labs. One is XRD lab. In this XRD lab, we have only a full-size XRD. Then metal research lab. In metal research lab, we are doing the characterization of materials electrically, magnetically, and the synthesis is also done in the same lab. Then nano research lab. In nano research lab, we are working on this nanoparticles. These nanoparticles can be used for catalyst or some other purposes. Then we have a hydrogen energy lab, then thin film lab, and computational lab. As all of you know that since we are a state university, so all the facilities available in the department can be utilized by any of the researcher in the state. And this is a small overview of department. Presently, department has three major courses: PhD course, dual degree MSc 5-year course, MSc 2-year course, BTech, and this MSc 2-year course have three specializations: condensed matter physics, as well as electronics and nuclear physics. And out of these three specializations, depending upon the choice of student and availability of staff, we continue with these specializations. Now let us talk about this FIST lab. All of you know that there is a program sponsored by Department of Science and Technology, New Delhi, that is called FIST program. Under this FIST program, some research grants are allotted to the universities, and under these research grants, we purchased many research equipments. In the present research grant, we purchased a fluorescence spectrometer, then MEMR loop tracer, then sputtering units, RF and DC, UV spectrometer for this NIR region, then temperature and humidity control cabinet, and impedance analyzer in the next phase. Okay. In addition to this department facilities, university also has a central instrumentation laboratory, and this central instrumentation laboratory has been established by myself in 2013, and with these four basic equipments. One is your FTIR mid-range, then DTA plus DSC, that is STA 1000 to 100 to 1000 degrees centigrade, impedance analyzer in gigahertz range, and UV spectrometer in normal range, that is your UV VIS and NIR. Now let us talk about some more detail about the departments. That department has XRD, integrated sphere, muffles, source meters, LCR meters, or we can say that some basic research facilities. Those can be utilized to synthesize and to characterize the material. And to establish all these facilities, department received a grant of 206 lakhs from 2012 to 2017. And in 2019 to 24, we have again received 146 lakh grant to establish some more advanced research facilities in the department. Regarding that, I have already mentioned all of you that what are our new instruments and how we can use these instruments for our latest characterization of materials. Okay, now let us talk about the awards and recognition. Of course, the Department of Physics has awarded with 2 Raman fellowships. One is Dr. Ravinder Kumar and another one is Dr. Pradeep Singh, who visited USA in 2016 and 2013. In addition to that, department is also recognized by a energy test center, and this test center was established by the funding of 1 crore from DST Haryana, and now recognized as Regional Test Center by MNRE, Government of India. And in this test center, we also have two research positions, and this is the first RTC in the North India having sorry NABL accreditation. And in our future plan, we also establishing a new testing lab that is called Solar Thermal and Energy Efficient Testing Lab. For this, a proposal has already been submitted to Department of MNRE, Government of India, and very soon we can say that we hope that very soon we will get this opportunity. And in addition to that, department also have international collaborations. Now let us talk about the publication. Of course, this is not a big thing, but since this department was established in 2010 and we have a faculty of 10 members, and at present in the last 5 years we published 150 nearly 150 papers in SCI index journals, 4 books, and if we're talking about the impact factor range, so up to 10 we have published the papers, and H index is nearly 30, and total citation of department is 3000. And in this research publications, the major papers, or you can say major journals, those are used to publish the papers: Physical Review Letter, Journal of Applied Physics, Solid State Ionics, RSC Advances, Ceramic International, Journal of Law and Compounds, JNCS, Petrochemical Act A, Physical Review C. And from this we can say that yes, we have some good publications. And this is again just a detail of that, how we have these research facilities and used by other state universities and the colleges and the participants. Sorry, this is repetition. Yes. Now let us talk about the expertise of the department. Of course, as I mentioned, that department has 10 faculty members, but if I'm talking the present status department has only 8 faculty members. Out of these, 3 are professors and rest are the assistant professors, and some are very close to associate professors. And if the areas department is working in the area of glass ceramics, and especially for the rare doped materials for white LED applications, oxyhalide glasses for optical windows, transition metal doped glasses for electronic and switching devices, and nanomaterials and magnetic fluids, then sensor and energy devices, nuclear physics, semiconductor oxide materials, and renewable energy. This is up to this. I have discussed a very short introduction of the department about the research. Now let us talk about a topic which is very burning nowadays, and that is about the materials which can be used as a white light LED emission. And in this direction we are doing a good work. That is, with the help of rare earth elements, we prepared some glasses, and these glasses are known as luminescent glasses. And these luminescent glasses are used as a white LED, or simply you can say LED devices. And this is just a brief that what is the meaning of this luminescent glass and how we achieve the LEDs. A brief introduction of your LED or your incandescent lamps or the bulbs. All of you know that in old days initially we are using incandescent lamps, then we use this CFL, and nowadays we are using these LEDs. Of course, LEDs has a lot of advantages as compared to your conventional mode of lights, like efficiency, color, size, on-off time, slow fluor, lifetime, environment friendly, energy saving, and low maintenance cost. Now, let us discuss a very brief about this white LED. Actually, all of you know that the invention of LED is very far. Or you can say that from very beginning, we know about the LEDs. They may be your red and green LEDs. But all of you know that if you want to generate white light, then it is not possible with these two LEDs. So to produce white light, the invention of blue LED play a significant role. And this invention of blue LED was done in 2014. And in the Nobel Award citation, the Nobel Committee declared the incandescent light bulb lit the 20th century, and 21st century will be lit by LED lamps, which will help to slow down the carbon dioxide emission worldwide. And rather, we can say that with 20% of world electricity use for lighting, it has been calculated that the optimal use of LED light could reduce this to 4%. This is a very big achievement. Nowadays, all of you know that more than 80% your lighting purpose was solved with the help of LEDs. And depending upon the environmental conditions, we will use different LEDs. And this is the basic of LED. All of you know that LED means light emitting diode. That is, you have a emitted light. This is modulated epoxy lens. This is Android wire, and this Android lead and cathode. Actually, you will see that this is your PN junction. Of course, we have a P-type GN, then active region, and then N-type region. And this is the process that how the photons are emitted or your light is produced. And now, I have already mentioned you that this LED. Of course, in LED, till now, the material that is used the phosphor. All of you know that phosphor and rings play a significant role in the emission of white light. Okay, but we know that this phosphorus coated, EC means phosphorus coated white LEDs. They have advantages as well as disadvantages. If I'm talking about the advantage, then temperature stability, simpler to create than RGB LED, then decent color rendering. And if you are talking about drawbacks, inhomogeneous white light emission, poor luminescence intensity, high correlated color temperature, less efficiency, short lifetime compared with other type of LED, phosphor converted white lights. And as a conclusion, we can say that although nowadays most of the LEDs are based on phosphor, but these phosphor based LEDs has itself a lot of disadvantages. And if we compare these phosphor based LEDs with a new technology that is called luminescent glass or glass ceramic, which represents an interesting alternative to LED phosphor due to their high thermal chemical stability. A series of rare earth glasses has been investigated for their potential applications as photon converters for solid state lighting applications. Now let us just compare some parameters of phosphorus coated white LEDs and luminescent glass white LEDs. Of course, in case of phosphorus coated white LEDs, decrease in luminescent intensity as well as efficiency, chromicity, deterioration and lifetime. And these things are not exhibited in case of your LG or you can say luminescent glass based white LEDs because scattering phenomena is very low in that case. Whereas if we talk about scattering loss in case of phosphor based LED, it is very large. Or in short, we can say that non-uniform dispersion of phosphor in an organic region. This is the main reason that why these phosphorus based LEDs starts decaying after a long use. And this is our duty, that how we improve the quality of these LEDs. And at present we can see that this luminescent glass based white LED are strongly accepted to be an interesting and excellent alternative. And this is some, you can see, the advantages or the best part of this luminescent glass white LEDs. They are excellent thermal resistant. They can play the role of luminescent converter as well as encapsulating materials. They do not exhibit the light scattering loss of the traditional slurry based with phosphor and organic resin rings caused by the large difference in the refractive index between them, and can give homogeneous emitted light and simple manufacturing process. So hence we can say that yes, if we are able to generate this kind of white LEDs, of course the quality of light is improved a lot, and this is in short. But we cannot say that the single component perfect. Still it has some challenges regarding low color rendering index, high correlated color temperature because of scarcity of red emission. And then how we achieve these things? Of course, to characterize the material for this white LED material, first of all, we must know about the optical properties of the material. And in this series, we developed a material that is glass-based material. And this glass-based material is doped with rare earth elements. Then, with the help of the information obtained from UV, VIS, NIS spectrometer, the different electronic states, or you can say optical band gap, degree of disorder, we can analyze it, and from there we calculate the fundamental absorption S and some intensity, absorption intensity, that can be signify the presence of your rare earth element. And by using this optical spectra, we can calculate various parameters: optical absorption coefficient, this optical band gap, and then band tailing parameters. And these parameters help us to characterize the material optically. Now let us talk about this photoluminescence. All of you know that the emission of an absorbed radiant radiation in the form of light is called photoluminescence. Of course, what kind of information we can gather from this PL? That is, we can get the best part, that is yellow to blue ratio, color coordinates, and correlated color temperature, because all these three parameters, they determine the quality of your white LED. That is, what is the order of YB ratio, what are the coordinates, and what are CCT. Of course, in this case, you will see that these you can say material are excited first with a wavelength of 451. How we select this wavelength 451? This selection is done on the basis of your absorption spectra. See from here at this point, this is 451, and this characteristic absorption play a significant role in your PL. That's why first we excite the material at this 4-5 nanometers, and then we receive the emission spectra. That is your blue light, then this yellow light, red, and etc. And this is the typical, you can say, a PL spectra. Of course, in this PL spectra, you will see that your emission wavelength is 477 nanometers. And this LF0, LF2, LF5, LF7, these are just the, you can say, samples, or LF means lithium fluoride based samples, in which we dope this with a rarer, that is dysprosium, and these are various peaks. By using these uh, intensities, that is at this intensity and this intensities, we are able to calculate the threshold values xyz. By using this color matching functions, uh, the chromatic coordinates xy can be calculated, and this xy calculated x is equal to capital X upon x plus y plus z, capital small y equal to capital Y upon capital X plus this. And finally, now let us talk about this CCT. By knowing the refractive index and its number, we can calculate this CCT. That is your correlated color temperature, which play a significant role in the LEDs. Now let us talk about some experimental part that we have carried out in our lab to characterize these materials. All of you know that first we synthesize the glasses. We synthesize the glass. For that we use these AR grade reagents, then weighing system, then grinding, finally high purity alumina crucible, then kept in a furnace, and finally quench. And this is the final glass. Of course, to characterize this glass, we must know that is it should have, you can say, amorphous in nature. And to know its crystallinity, the XRD is carried out. And in XRD, you'll see that there is no sharp peak is obtained in the XRD, just the humps. Of course, these humps are due to the overlapping of planes. And we can confirm from here that yes, what we want to synthesize, we synthesized. That is a rare earth dope lithium fluoride calcium bismuth borate glass. And this is some FTIR spectra just for this functional knowledge of functional groups. We are not much more bothered about that, because our main focus is on this optical and PL properties. And this is, see, just the various bands, those are available in our materials, or you can see the parameters, those can be calculated from this FTIR. Now let us talk about some thermal behavior. All of you know that these materials are also studied thermally, because by knowing this TG, that is called your glass transition temperature. गुन्नू बेटा एक बार देखो ना, एक बार गुन्नू बाहर देख बेटा एक बार. Sorry dear students for increments regretted. In addition to that, we have also characterized these materials electrically, and from this electrical means we plot a graph with log of Tc versus 1000 of T, and we calculate various parameters. Of course, out of these parameters, these two terms are very important. That is Tg, that is 537 and 522, means these glasses are thermally stable. This is what we want to know from this DTA curves. Okay, now let us talk about this optical parameters. As all of you know that by using this optical absorption spectra, we are able to know the cutoff wavelength, the optical band gap, and the Arbach energy. Of course, all these parameters are used to characterize the material optically. And this is finally, we can say that the PL, that is the excitation spectra for at 577 and emission spectra at 451. Okay. Okay. And if we're talking about the parameters, then these are the various parameters that we obtained from these spectra. This is, of course, in this case, we can talk about the chromaticity diagram. Of course, all the parameters, those we have calculated, these are called your XY parameters. And from this uh, chromatic diagram, it is found that these parameters are very, very close to white region. That's why we can say that the prepared materials can be used as a luminescent glass for white light emissions. And these are the some parameters I have already mentioned you. To know the best material for white light emission or luminescent glass, we have to know the value of YB ratio, color coordinates, and CCT value. And out of these parameters, if we focus ourselves on this 10th sample, of course, the value of this YB ratio is very close to identical value. And XY coordinates are again very good. That is 0.332, 0.37. And CCT values again of the order of 5,000. So from this data, we can say that if we are able to synthesize, able to make a device from this material is suitable for white light emissions. That's why we are saying that the white light LED materials. Now let us compare these parameters with some other series. Of course, in addition to this lithium fluoride, we have used lithium chloride, we have used lithium bromide, we have used sodium chloride. And all these four series, if we see that the best compositions is what? That is 0.33 and 0.06, means the lithium fluoride base oxide glasses topped with rare earth are the most suitable material for this white light emissions. In addition to that, if we're talking about their CCT value, if we're talking about their TG, if we're talking about their conductivity, all parameters are best suitable parameters for these materials. And this is simply a comparison, or you can say that how we obtained this LG white LEDs, that is luminescent glass white LEDs. Extended work. Now at present we are doing to improve the quality of glass with double rare earth doped glasses. Of course, in our previous slides, I just say that some red emission play a non-significant role. So our aim is that how we reduce this red emission, because blue and yellow itself is sufficient to produce a good white light. So to improve the quality of white light, now double array earth doped glasses are in work. And this is some details about this. For white light, the temperature stability of phosphor on the top of its vital importance during operation. The white light reach junction temperature from 150 to 200 degrees centigrade. In case of high power LEDs, the light junction temperature lead to a significant change. Means if we are able to generate these luminescent glasses, certainly they are better option for these LEDs. And these are some other examples of this rare earth elements. And these are some good news of the department. And thank you for your patience. Thanks a lot. Now session is open for questions. Yes? Any question, Dr. Sundar? डॉक्टर सुरेंद्र, आवाज नहीं आ रही आपको? डॉक्टर सुरेंद्र, आपको आवाज नहीं आ रही? हेलो, हेलो, डॉक्टर सुरेंद्र, यू आर म्यूट. डॉक्टर सुरेंद्र, you are mute. डॉक्टर सुरेंद्र, आप म्यूट हैं. ओके, कोई नहीं, you just share my email ID. If there is any question regarding this presentation, I will certainly answer all about that. Can I stop? डॉक्टर अशोक, चलिए, let me close. Okay, 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 okay. Dr. Sundar, can I leave? No issue, no issue. कुलदीप यार, ये आवाज क्यों नहीं शेयर हो रही है? मेरे को डॉक्टर सुरेंद्र की आवाज नहीं आ रही, और फोटो में भी दोनों जगह डॉक्टर सुरेंद्र का आ रहा है, मेरे उसमें भी ये स्क्रीन ठीक से काम नहीं कर रही. हाँ डॉक्टर विंदर, इनके आंसर. अच्छा, चैट में. ओके, चैट में. Hompal, I think host is not in the meeting. Please be participant. क्वेश्चन तो कोई अलग से नहीं है किसी में. हाँ 433 के बाद कोई क्वेश्चन नहीं है, बोलो आप। That is from optical spectra. Of course, each rare earth element has its own absorption wavelength. So just by knowing the absorption wavelength, we get an idea about the excitation, and then by using these excitation wavelengths, ये कितने नंबर क्वेश्चन है, कहाँ ये क्वेश्चन है? हाँ नहीं, मैं चैट बॉक्स ही खोल रहा हूँ मैं। नहीं, मेरे पास तो ये 743 का लास्ट चैट है। ऊपर नहीं यार, मेरे पास तो है ही नहीं, कोई नहीं है।
हेलो,
भाई अशोक की आवाज आई अभी।
मैं वो करता हूँ सर, सभी मेरे नेटवर्क की प्रॉब्लम थी सर इधर से ना।
मोस्ट हैज म्यूटेड।
अलाउ पार्टिसिपेंट मैंने कर दिया सर सबको।
हेलो, हाँ जी सर।
हो गया सर।
सर मैं म्यूट था इसलिए नहीं बोल पा रहा था।
हाँ हाँ हाँ,
ओके सर, ओके, थैंक यू सर, थैंक यू। एक वेट, थैंक यू सर फॉर सच ए वंडरफुल टॉक। योर एक्सपीरियंस टॉक हैज मेड आवर डे।
ओके,
इट्स वेरी अमेजिंग टू हैव सच ए ग्रेट पर्सन विद हुज नॉलेज। Again, thank you sir for sharing information regarding advanced facilities available in the Department of Physics to our learned participants, because this proved very fruitful for collaboration of active researchers. Dear participant, you can visit to our department and avail this advanced facilities. Thank you sir, thank you very much for such a wonderful.
Thank you Dr. Surinder for this good opportunity, and I must thank all the participants who listen my talk carefully and pay a good attention. Thank you again.
Thank you very much sir for
सर आप देख लो अशोक।
हाँ जी
सॉरी
सर,
मैं इंटरप्ट किया आपको, सॉरी।
हाँ जी।
ये
आप देख लो
डॉक्टर रविंदर
जी
मेरी स्क्रीन फिर डिस्टर्ब होगी है, मैं उसके चैट में डाल दूंगा इनके आंसर।
ओके सर, ठीक है,
व्हाट्सएप ग्रुप में डाल दूंगा।
ओके सर, ओके ओके।
अब वैसे तो ना इसमें सर वो सिंपल से पूछ रखे हैं कि फैसिलिटी अवेलेबल कैसे होगी हमारे लिए। आर द फैसिलिटीज अवेलेबल इन DCRUST कैन बी यूटिलाइज्ड बाय अदर इंस्टीट्यूट्स फैकल्टी।
हाँ, वो आप अशोक इनको बता दीजिए, कोई दिक्कत नहीं, डाल दीजिए, उसमें हम कर देंगे।
और फिर भी मैं आपकी मेल आईडी भी दे दूंगा सर ना, सभी को
ठीक है।
कोई डिस्कस करना चाहेगा आपसे वो पूछ लेंगे सर, नंबर भी और मेल आईडी भी सर।
ठीक है जी, थैंक यू।
वो तो डॉक्टर साहब ने बोल दिया, उन्हें रिक्वेस्ट करी इनके ये दे कैन विजिट योर डिपार्टमेंट एंड यूनिवर्सिटी एंड अवेल फैसिलिटी।
हाँ जी सर,
ओके जी, थैंक यू।
थैंक यू सर, थैंक यू।
ओके सर। So thank you very much, Dr. Surinder Duhan, for chairing this session in a nice way.
Thank you, sir.
Due to network problem, I was unable to answer your call. So now let us wind up for this day. Thank you very much. Thank you to all of you. So we end here the today's session. So tomorrow as the last day of our 1 week faculty training program, and we will meet in the morning with the professors. Sunita Srivastava will be our speaker in the morning, first half of the morning session. She is from Guru Jambheshwar University, and then we have Professor Kedar Singh from Guru Jambheshwar from Jawaharlal Nehru University, New Delhi. So thank you very much. Thank you being with us and listening all the sessions with patience. Thank you very much. Thank you, Dr. Surinder. I am going to end this meeting.
For giving me the opportunity.